In this video, we'll take a look at section 4.6, which is special factoring. Now, before we get into special factoring, we're going to take a look at a review for the power rule of exponents. Now, what the power rule states is if x raised to the nth power is raised to the nth power, now what we do is we multiply the exponents together. This would become x raised to the m times n. So an example, if we have x to the third power raised to the second, all we have to do here is multiply the exponents with each other. This would become x raised to the 3 times 2, which gives us x to the 6th. And that's how the power rule of exponents is used. If I were to work this out a different way, x to the third raised to the second, this would be x to the third times x to the third. And if I expanded out each one of these x to the thirds, this would become x times x times x times, and then the next x to the third would be x times x times x. If I rewrite this in exponential notation, this would be x raised to the 6th, just like what we got over here. But now instead of expanding it out completely and then combining back together in exponential form, I could go ahead and use that power rule. Now, the main reason why I'm showing you this review for the power rule is we're going to be starting off with, say, x to the 6th, and I want to rewrite it into this form. Okay? And we'll take a look at that in this section. Now, special factoring, we're mainly going to be taking a look at factoring binomials. So our first objective, we're going to factor differences of squares. Differences of two squares, this is if you have something raised to the second power minus something else raised to the second power. We have a formula to factor this out. What this factors into is a minus b times a plus b. Now, if you have a sum of two squares, if you have something squared plus something else squared, this cannot be factored. So you might think, okay, probably factors into a plus b times a plus b. But remember, whenever you want to check your factorization, go ahead and multiply it back out. A times a, I get a squared. A times b, I get ab. Distribute out this b. B times a, I get another ab. B times b, I get b squared. And now if I combine like terms, I get a squared plus 2ab plus b squared. But notice how this is not what we originally started off with. Okay, so sum of two squares, we cannot factor those out. Those can't be factored. Only differences of two squares. Let me just erase this, and then we'll take a look at an example. Okay. So first example, factor y squared minus 4. So the way that this is written, we can't see that it's the difference of two squares. We don't see it's something squared minus something else squared. But what we can do here is we can rewrite it into this form. So for example, y to the second power, I could rewrite this as y and then to the second power, minus, and my 4, I can rewrite that as something squared. As a matter of fact, I could write it out as 2 squared. Now I have it in the proper form. I have something squared minus something else squared. So this y, this would be like my a in the formula, and this 2 would be like my b in the formula. So when I factor this out, I have y minus 2 times y plus 2. And now we completely factored out that binomial. If you want to check your answer, go ahead and multiply it out, and you'll end up with the same thing that you started off with. You'll end up with y squared minus 4. Let's take a look at another one. Okay, so factor 49x to the 4th minus 25y to the 10th. So now this one's a little bit more difficult to rewrite in that form. Okay, so I want to rewrite this as something squared minus some other term squared. Take a look at 49. Can we rewrite 49 as something raised to the second power? You sure can. Write it out as 7 raised to the second power. But now this x to the fourth, a little trick that you can use here, divide the 4 by 2. So 4 divided by 2, we get 2. So if I put x squared inside the parentheses, this will work out. Because 7x squared times 7x squared, that gives me that 49x to the fourth. Now for the next term, I want to rewrite 25y to the 10th as something raised to the second power, as some term raised to the second power. I could rewrite that as 5y to the 5th. Because 5y to the 5th times 5y to the 5th, that gives me 25y to the 10th. Now I have it in this form, I could go ahead and use my formula. This would become 7x squared minus 5y to the 5th times 7x squared plus 5y to the 5th. And now it's completely factored out. Let's take a look at a couple more with factoring differences of two squares. Now our next problem, we have 20x squared minus 5y squared. Remember, our main goal is we're trying to write it out as some term raised to the second power minus some term raised to the second power. But if you take a look here at 20, I can't rewrite that as something raised to the second power. But if you take a look at these two terms, you realize that you have a GCF. So I can factor out that GCF to start. So I'm going to, our GCF here is 5. So I'm going to factor out a 5, and now I'm left with 4x squared minus y squared. So now what I have left over in the parentheses, I can rewrite this as some term raised to the second power minus some other term raised to the second power. I could rewrite it as 2x raised to the second power minus y raised to the second power. So to continue, we still have our 5 in the front. That was our GCF that we factored out. And now inside the parentheses, that binomial, this factors into 2x minus y and 2x plus y. Okay. So if you're not able to rewrite the original problem as some term squared minus some other term squared, check and see if there's a GCF first. If there is, factor that out. And then go ahead and see if you could rewrite it as a term squared minus another term squared. Okay, next problem. So I have 25, we want to factor 25x squared plus 36y squared. So I can indeed write these as some term raised to the second power and some other term raised to the second power. I can write it as 5x raised to the second power, and then plus 6y raised to the second power. But be careful here, this is not a difference of two squares because we have that plus in between them. This is a sum of two squares. And what we saw about sum of two squares can't be factored. So differences of two squares, you could factor those out. Sum of two squares, you cannot factor those out. So now we take a look at our next objective, which is sum or differences of cubes. So a difference of two cubes, this is when you have some terms cubed minus another term cubed. The formula for factoring this out, this would be a minus b times a squared plus ab plus b squared. Now a sum of two cubes, you could actually factor this out. So if you have a term raised to the third power plus another term raised to the third power, this factors into a plus b times a squared minus ab plus b squared. So these two formulas are very similar to each other. The only difference here are these two signs. Your main goal is to rewrite it so it is a term cubed plus another term cubed, or a term cubed minus another term cubed, and then you use the formula to factor it. Let's take a look at an example. So we want to factor x to the third minus 8. Okay. So you might think, okay, why isn't this a difference of two squares? Well, x to the third power, I can now rewrite that as a term raised to the second power. However, each one of these terms, I could rewrite those as something raised to the third power, some term raised to the third power. Our first term, this would be x raised to the third power minus, and now 8, I can rewrite that as 2 raised to the third power. So now I have the form of a difference of 2 cubes. I can use the formula now to factor this out. This x is like my a, and this 2 is like my b. Let's go ahead and use that formula. I have x minus 2 times, now it's this term raised to the second power, so I have x raised to the second power plus, now it's my x times 2, which gives me 2x plus, and now it's my b term, my 2, raised to the second power, which is 4. And now I have it factored. Let's take a look at another one. We want to factor, we have 27x cubed plus y cubed. So if you take a look at this, we have this in the form, so this is, we could rewrite this as a term raised to the third power plus another term raised to the third power. So this is a sum of 2 cubes. This 27x to the third, I can rewrite this as 3x raised to the third power. Plus y to the third, I can rewrite that as y to the third power. And now I go ahead and use my formula. So with my formula, my a is like my 3x, and then my y is like my b. So I'd have 3x plus y times, now it's 3x times 3x, so it's 3x raised to the second power. That gives me 9x squared. And I have minus 3x times y, which gives me 3xy. And I have plus y raised to the second power. And now it's factored. Let's take a look at another problem. Our next problem here, we have m to the 6th minus n to the 6th. So this particular problem, okay, we do have a minus in between our two terms, so you want to check if it's a difference of 2 squares or a difference of 2 cubes. Well, in this particular case, you could rewrite this as both. For example, if I rewrote it as a difference of 2 squares, I could rewrite as m to the third raised to the second power minus n to the third raised to the second power. If I wrote it out as a difference of 2 cubes, I could rewrite it as m squared raised to the third minus n squared raised to the third. Now, whenever you have the option, whenever you're able to rewrite it as a difference of 2 squares or a difference of 2 cubes, always go with the difference of 2 squares first. It will make your problem a lot easier to factor out completely after you use that formula. So let's go ahead and rewrite this as a difference of 2 squares, and then we'll go from there. So m to the 6th, I'm going to rewrite it as m to the third raised to the second power minus n to the third raised to the second power. So now I have a difference of 2 squares, so let's go ahead and use our formula. So we have m to the third minus n to the third times m to the third plus n to the third. But now each one of these binomials, I could factor out some more. So the first binomial I have right over here, this is a difference of 2 cubes. So let's go ahead and use the difference of 2 cubes formula to factor that out. So I would have m minus n times, I have m squared plus mn plus n squared. And now we have this other binomial, which is a sum of 2 cubes. I can factor that out. So using our sum of 2 cubes formula, this would be m plus n times m squared minus mn plus n squared. And now it's completely factored out. So just to recap, whenever you have the option, or whenever you are able to rewrite that binomial as a sum, or I'm sorry, not a sum, as a difference of two squares or a difference of two cubes, always choose difference of two squares. And the reason for that is it will make your life a lot easier to factor out what's left over. So let's take a look at one last problem. So factor 16x to the 7th y plus 54x y to the 7th. So we have a lot going on in this problem. But first take a look at if there's a GCF. So in this case, there is a GCF. 2 can go into both 16 and 54. Because if you were to originally start off this problem, 16, I can't rewrite that as some number raised to the third power. And 54, I can't do that either. So let's go ahead and see there is a GCF. They both have a 2 in common. They also have an x in common, and they also have a y in common. So I'm going to factor out 2xy. So I'm left with 8x to the 6th plus 27y to the 6th. Now, inside of our parentheses, there's a plus that separates the two terms. Check to see if you could rewrite this as a sum of two cubes. Now, my first term, this 8x to the 6th, I can rewrite this as 2x to the 2nd raised to the 3rd. And then my next term, I can rewrite this as 3y to the 2nd raised to the 3rd. So I rewrote it in the form of a sum of two cubes. So now let's go ahead and factor that out. So this GCF is going to stay on the outside. Put this in a different color. So this 2xy stays there. Now I'm factoring out what's inside the parentheses. So I have 2x squared plus 3y squared. So using the formula, this is like my A and this is like my B. And now it's the next part of the formula is a squared. So I have 2x squared raised to the 2nd power. So 2x squared times 2x squared, that gives me 4x to the 4th. Then I have minus. This is a times b now. So 2x squared times 3y squared. This gives me 6x squared y squared. Plus, then I have b squared. So it's 3y squared raised to the 2nd power. So 3y squared times 3y squared, I get 9y to the 4th. Now I am done factoring out this problem. So that was it for this section. As always, if you have any questions, email me.